Hello, my name is Tyler Dunaway, and I will be presenting my project in Physics 2020 on the technology of Maglev trains. What is Maglev? Well, Maglev is simply an abbreviation for magnetic levitation. It involves trains, in which case that we will talk about, but it also involves other technologies. In this case, trains that levitate above and around tracks that are propelled by electromagnets that cause them to move. Although this seems like a very complicated and difficult subject to grasp, it was actually very easy. I thought that I was going to struggle more grasping the concepts, but after reading more about it, we have pretty much talked about all the things that make maglev trains function through our topics we've discussed in class or through, online stuff. Maglev trains, a big advantage of them is that they allow rapid transportation for a lot of people. Some people may have an hour commute to work, but not everyone needs to fly on a plane for an hour commute to work. Some of these maglev trains in bigger cities allow tons of people to get in and out of cities very fast and very efficiently. The first maglev train was in China in 2003 when it came onto the public. So kind of this is relatively a little bit of a newer technology. We don't see it as prominently today in the United States unless you're in a major city like New York or Chicago or something like that. These trains are very safe. There's only been a couple recorded accidents of them since 2003, and the ones I read about were from like 2006 or something like that. I couldn't find any that have happened since then, so I think this technology is actually growing very fast and it is becoming much safer and safer. Like I said, the biggest advantage of this is it allows people to move from city to city in a fraction of the time that they would. Similar to planes, because these things travel so fast, they aren't as fast as a plane flying in the air, but they usually go around 200 miles an hour that I found, sometimes more, sometimes less, but regardless, you're not going to be going 200 miles an hour in a car on your commute to work. So this is a great technology that we hope to see more of in the future in the United States. These function basically on electricity and magnets in their most elementary form, I guess you could say. Magnets, we all know, have similar properties to electricity in their poles and charges. Magnetic poles have north and south like poles. Repel, dissimilar poles will attract. Likewise, protons and electrons attract, and protons repel, and electrons repel similarly if they're together. We see in these next two bullet points. Magnets and electricity are actually related very closely, as we know that magnets can make electricity and electricity can make magnets. We have magnets making electricity through rapid motion and creation of changing magnetic fields very rapidly causes electrons to move and create electricity. And we all know how electricity makes magnets through induced voltage and currents. Something like wrapping wire around a nail and attaching it to a battery, something like that. Electromagnetism is the marriage of these two things, like it says in the name. It's the branch of physics that deals with the interaction of electricity and magnetism. It deals with things like forces between two charged particles that produce magnetic fields, whether that be two alike particles or dissimilar particles, and what energy they produce together, and the fields that they create just by being there. Faraday and Coulomb's laws are two very crucial formulas in magnetic levitation that I will discuss now. Faraday's law of induction studies how magnetic fields interact with an electric current, produce electromagnetic force, which is EMF. We see that denoted by E here. It's simply, like I said, the creation of electricity through magnets, so it is or changing magnetic fields. So we have our number here, and then we have our number of magnets here, or terms, and then we have our delta of phi, which is our change in flux, and our delta of t, which is our change in time. So basically the number of what wraps around something multiplied by the change in flux divided by the change in time. and that is measured in volts too. Coulomb's law deals with forces created between two charged objects. Force, as we see here by the F, it's a vector quantity, which means it will have a magnitude and a direction and is measured in newtons. So K, we see here, is a proportionality constant of Coulomb's law. Usually we denote it as it would be in air, but it can differ if it was in water or something like that. But in air, we usually say that as 9 times 10 to the 9th newtons per meter squared. The Q's you see here are the charges, the quantitative charges of an object. So we have multiplied those over the distance between those two objects squared, and that will give us the force in newtons that Coulomb's law gives us. Here we see that how maglev is used in trains through tracks and alternating charges and electromagnets along sides of tracks. This is a little bit easier to look at first, as we see how the train moves forward with the attraction of these particles right here that pull it forward, and the repulsion of these right here, which keep the train moving forward as well. This is a little bit dissimilar to the usual one that I see, in that you see the wheel support, and most maglev trains don't have wheels. We see the levitation and guidance will most of the time be on the undercarriage of the trains. That's what keeps them above the ground. But some of these trains do have wheels that they're required to have at lower speeds because the propulsion of the magnets can't keep them moving up at a lower speed. These beams that we see the train usually travels through, and these are the propulsion coils right here that you would see by these N and S's that alternate and repel the train forward when an electric current is induced through them. These are the guidance rails we see. This is what I was talking about more. We see these magnets lined up right here that push the train up in the air and allow it to levitate. And this might be a good time to say too, I talked about earlier how fast these trains move, and most of the time that's due because these things hover, not because of the energy through them. One might think it's just because of the propulsion, but the real killer here is friction. And without friction on these trains with rails, the only real friction you have going is air resistance. And with the right aerodynamics and train engineering, it's easy to reduce that to a very low rate, so trains are able to move even faster since there's no resistance of tracks and trying to stop it so fast. It's able to easily go and start. So why the push for maglev, since we don't see it as much? It's some of the most eco-friendly source of energy we have for transportation today. Magnets require nothing but electricity, which doesn't really burn fossil fuels like we think in cars that use gas or diesel or jet fuel in planes. And so when we have these sources of electricity, there's hardly any emissions at all, which allows for great technology and eco-friendly energy that there's a huge push for in the world today, as we talk about the ozone layer and stuff like that going down in the environment. You would think that if maglev trains are so popular, why aren't cars out today? Or why don't we hear about maglev often? Cars typically now, we have electric cars, but most of them can only go up to 50 miles or so on a tank, and they still are hybrids between gas and electricity. So science is starting to engineer cars that use electricity and maglev. As we talked about earlier with the limited friction here, you have even better you have even better mileage and less friction that allows for more and more efficient energy. The only problem is roadways don't have magnets in them today, and so it's hard for us to have this technology now, but we never know. We never thought landing on the moon would be possible, but we did that forever ago. So as technology develops and things happen, who knows where the world will be or where the world will take us here in 15 years. This maglev technology in general is a very present thing and is evolving, and is something that we will see more and more in our daily lives, I feel, as the technology advances and the need for cleaner, more efficient energy continues to develop everywhere. Here are some of my references. These will be listed in my essay as well. Thank you very much.